Dot school presents triangles. I'm sure you know what a triangle is. To define that formally, a triangle is a polygon with three sides and three angles in it. There are a few special types of triangles you want to know about. In an equilateral triangle, all the three sides are exactly the same length. In an isosceles triangle, only two sides are the same length and the third side is of different length. So in this triangle over here I have drawn, this side is the same length as this one, but the third side, the base of this triangle, is different in length from these two. And for an equilateral triangle, of course, if you want to show them all the same length, you can put these marks and they indicate that they are all the same length. In a scalene triangle, all three sides are different in length. So this side is different in length from this side, and they are both different in length from this side. Triangles can also be classified as acute, obtuse, or right triangles based on the angles they have in them. In an acute triangle, all three angles are less than 90 degrees each. This angle out here and this, they all are each equal to something less than 90 degrees. In an obtuse triangle, one angle is more than 90 degrees. This angle out here is more than a 90 degrees or a right angle, and this triangle qualifies as an obtuse triangle. In a right triangle, as the name implies, exactly one angle is equal to 90 degrees. So you have a right angle or a 90 degrees over here. And there's a special name given to the side that's exactly opposite the right angle. So it's this side in this particular triangle. And it's called the hypotenuse. No matter what the type of triangle, all triangles share some common properties. The sum of the three angles in any triangle is equal to 180 degrees. Let's go ahead and try to prove that. And to be able to do that, you need to know something about parallel lines. So if you have two lines that run parallel to each other, this one is parallel to this one, and they're cut by another line that's referred to as the transversal, then this angle out here is exactly the same measure as this angle. They're referred to as the alternate interior angles. Alternate because they lie on the opposite sides of the transversal, and interior because they lie in between the two parallel lines. And similarly, this angle is the same measure as this angle because they form another pair of alternate interior angles. Let's say we have a triangle. Let me just name it as A, B, and C. And we want to prove that the sum of this angle and this angle and this angle, they add up to 180 degrees. And to be able to do that, what I'm going to do is, I'm going to draw a straight line through point A. You could pick any of the 3 points, it doesn't matter. That is parallel to the opposite side. In this case, BC. So essentially, this line is parallel to this line. Now this angle out here is the same measure as this angle out here because they are two parallel lines cut by the transversal AB, so they form the alternate interior angles just like over here. And if you understand that, in the same way this angle out here is exactly the same as this angle because the transversal in this case is the side AC of the triangle that cuts the two parallel lines. And then if you look at angle A inside that triangle, it's pretty obvious that these three angles, this and this and this, add up to 180 degrees because they are on a straight line. But this one is equal to this one, therefore this one and this one is equal to this one, therefore this and this angle A, they have to add up to 180 degrees. So if this is X, this is also X. If this is Y, This is also y. And that angle A is common. So we could say x plus y plus angle A is equal to 180 degrees. Now if you replace angle x with angle B, because we just have proved using the parallel line and the transversal concept that angle x is exactly the same measure as angle B. So you have angle B plus angle C, y is angle C plus angle A is equal to 180 degrees. And these are nothing but the three angles inside the triangle. Easy, right? Now, if you go back to that page where I defined the different types of triangles, now that we know that the three angles in any triangle will add up to 180, exactly 180, nothing less and nothing more. In an equilateral triangle, all the three angles are the same measure. Now, given that they have to equal to 180 degrees in all, each one is a 60 degrees. In an isosceles triangle, the angles opposite the equal sides, so this angle is opposite to this side and this angle is opposite to this side, they are also equal. And therefore, if you know one of them, you get to know the other one, and therefore, because the sum of the angles is 180, you can pretty much find the non-equal angle. In an acute triangle, if you remember, I had said that all the angles are less than 90 degrees. But for an obtuse angle, I had said that one angle is more than 90 degrees. And the reason is, you cannot have two angles more than 90 because they all have to add up to only 180. That's the limit. And in a right triangle, because one angle is already at 90 degrees, it implies that the other two have to add up to another 90 so that the three add up to 180 degrees. An exterior angle in any triangle is equal to the sum of the two opposite interior angles. So if we have a triangle and you go on to extend one of the sides to make it a little longer, to go beyond the triangle like I did over here, this angle out here is equal to the sum of this angle plus this angle. Now how can you prove that? It's pretty easy. Assume this angle to be equal to x. So what's this angle? Because this is a straight line, this has to be 180 minus x. Because the two, after all, add up to 180 degrees. Now, if you want to name this angle as y and this angle as z, it goes that because all the three angles inside the triangle add up to 180, we know that by now. So we have y plus z plus 180 minus x. It's this angle, y plus z plus 180 minus x. All of that add up to 180 degrees. They are the three angles, y, z and 180 minus x. They're the three angles inside a triangle. And if you take the 180 and the x on the other side, subtract 180 from both sides and add x to both sides, what you have is y plus z, this part is the same, y plus z, these two cross off, is equal to 180 and 180 cross off is equal to x. So this angle is equal to the sum of these two angles. And you can pretty much say the same thing if you were to extend any of the other two sides. The Pythagorean theorem applies on right triangles only, and it tells us that if you have a right triangle, that is a triangle with a right angle or a 90 degrees in it, remember the side opposite to the right angle is called the hypotenuse. Let's name the vertices of the triangle as A, B and C. The Pythagorean theorem tells us that the square of the hypotenuse, so you have square of the hypotenuse, is equal to the sum of what? Of the squares of the other two sides. Which means in this case, you have AC as the hypotenuse, so AC square is equal to the other two sides are AB and BC. So this is what you have. If you know the lengths of any of these two sides, you can easily find the other one by applying the Pythagorean theorem. There's one more important thing you want to know about triangles, and that is the sum of the lengths of any two sides on a triangle is always greater than the length of the third side. Let's say we want to draw a triangle whose sides are, let's say, 10 centimeters, 3 centimeters, and 5 centimeters. I have decided that I'm going to make the 10 centimeter line as the base of my triangle. And let's say I want to draw the 3 centimeter side from this end of the 10 centimeters side. I'm going to draw a circle whose radius is 3 centimeters and whose center is this point, so that my 3 centimeter side can be at any point on this circle. I mean, this is also 3 centimeter length, so is this or this. Because the circle itself has got a radius of 3 centimeters, I can pick any point on the circle, and its distance from the center of the circle, which happens to be one end of this straight line, will always be 3 centimeters. So this is a 3 centimeter length. Now I'm going to do the same on the other side, draw a circle whose radius is 5 centimeters with the center at the other end of this straight line, which means whenever I connect a point on the circle with this center, I get a straight line whose length is 5 centimeters. And that's exactly what I was looking for, 5 centimeters. So I have a 10 centimeters, I have a 3 centimeters, I have a 5 centimeters, but the problem is they don't form a triangle. This end doesn't close. These two lines do not meet at a point. Your best chance to make them meet at a point is bring this 3 centimeters closer and closer to the 10 centimeters and bring this 5 centimeters closer and closer to the 10 centimeters line. But even then, this can come down to this point and this can come down to this point. I know the picture is not drawn to scale, but the point is you will not be able to make them meet if this number and this number doesn't add up to the length of this line. And they can just touch each other. Imagine the two circles to be touching only when this number out here and this number out here just adds up to this number. But even then, that would be just a straight line. That won't be even a triangle. So to get a triangle, we have to make sure that these two add up to a number that's larger than this number, so that they get a chance to meet somewhere above this straight line, so that at least we could have some sort of a triangle there. Time for a couple of problems. Let's say we have an isosceles triangle. With one of the sides of the triangle extended, as you can see. These two are the equal sides on the triangle. Let me name this angle as x, and let me also say that this angle over here at the top, let's say, measures 40 degrees. Can we find the value of x? Let's say this is x degrees. So can we find what's x? Note that in an isosceles triangle, the angles opposite to the equal sides are also equal, which means this angle out here is exactly the same measure as this angle out here. And because all these three angles add up to 180 degrees, we have 180 degrees minus 40 degrees, which is equal to 140 degrees. They're all in degrees. 180 minus 40. So if you take out the angle at the top, you get the sum of these two angles. And when they're equal, that means each one of them is going to be 70 apiece. You just divide 140 with 2. This is a 70 and this is a 70. They're both equal and they have to add up to 140 degrees. And that gives you the value of x. X plus this 70 out here add up to 180. Therefore, x is going to be equal to 110 degrees. Let's try another one. Let's say we have a right triangle this time. So this is the right angle. It's given that this side is a 13 and this side is a 12. Can we find out the length of this side? Well, this is a direct application of the Pythagorean theorem that tells us that in any right triangle, the side opposite to the right angle, which is called the hypotenuse, if you square that, which means if you do 13 square, that's going to be equal to the sum of the squares of the other two sides. So this is going to be equal to 12 square plus whatever this length is. Let's call that x for the moment. So this is going to be equal to x square plus 12 square. 13 square is 169, and that's equal to 12 square is 144 plus x square. Take the 144 on the other side, meaning subtract 144 from both sides. You get 25 is equal to x square, which means x is such a number that you multiply with itself to get 25. So what's x? X obviously is equal to 5.